Hi, my name is Martin Smith, and I'm here to talk about beta decay today against the hyper-vortex model. That's where vortexes make up particles. The process in which I'm using to come up with these models is to look at observations done throughout physics, pick out ones that sound feasible to me, sound not contrived, take those observations and reverse engineer them back into how a vortex wave might propagate. One of the interesting ones is through Feynman diagrams, and I read a diagram incorrectly. First thing I'm going to go over is how easy it is to improperly reverse engineer something. If you reverse engineer something with wrong information, then theoretically it still looks like it's going to work. However, this is one of the problems with reverse engineering. You have to have proper information to start with, and that's the first thing you have to have. The second thing you have to have is you have to guess right. That's saying you pull stuff out of your back pocket and it just happens to work on the first time, which is generally rare. So if you're doing exploration or if you're reverse engineering trying to get a particular product or to remake something, then you have to understand that your first attempt almost never works out. You always have to go back, look at your final product, and improve it. Get it an idea to the point where I can't prove it wrong, put it on video, and see if I can't get it to crash somewhere. So far, these vortex models that I've been working with, I pretty much renamed them hypervortex models, because they're a different type of vortex than normal vortexes. They're spinning, but they're what's keeping them stable is them being up against a shock wave. And in this case, the shock wave is the speed of light. For photons, for electrons, protons, neutrons, the shock wave is a velocity, one directional velocity, speed of light. And for black holes, the shock wave would be a speed of light shock wave in both directions, creating a wave chamber. And this is what I'm going to be going over first, of how me misreading a Feynman diagram ruined my model of how a black hole worked through the vortex model. And you have to remember, when things don't work, we question it. When things work out the way we want to, we don't question it. If this would have worked out well, this mistake that I made would have worked out well, I wouldn't have questioned it, I would have gone on. So it's something that you should think about as you watch all my videos. And I'll get to the paperwork. Okay, starting with this mistake on this Feynman diagram, this wasn't put on here. And in all the Feynman diagrams that I looked at before, time went in this direction. It went from left to right. So I was reading this as we have an electron hitting a heavy photon and turning it into a positron, hitting another photon, turning it into an electron. And under that model, it would work like this. And that model actually worked in the vortex theory, and what happens is a photon with a negative and a positive come through, hit a negative. So what's happening is that the negative photon with radius or with spin in that direction hits another electron with spin going in this direction, and when they hit and the spins reverse and they go backwards, and when they do this, the photon turns into a positron and the electron turns into a photon. And this method does not work, and it does fail. So let's look at things the proper way. So if we look at other Feynman diagrams where time is going from bottom to top, and we look at this model that way, then what we're looking at is a photon splitting up into a positron and electron. And the positron with another electron are merging back into a photon. So Feynman diagrams are very sloppy, and they did get me into a bit of a mess. Okay, looking at a black hole, I'm pretty much saying that it has a spin one direction or another. It doesn't really matter, because if you look at it from another direction, the spin automatically reverses. So if the vortex waves don't interfere with each other, then you have one of them spinning this direction, hits the wall, bounces back, and reflects the other direction. What's holding it in is a resonance chamber of its own making, so that photons of a diameter, the center part of the photon, as soon as it hits the black hole, it stays in it and becomes part of the black hole, with the only thing coming out of it being able to force its way out is high spin energy from the center. And this is where spin energy and separate it from directional energy or linear energy. It's just one of those things, like the hair on the back of my neck says it works this way. Don't know that it does, and it's just an idea. I wouldn't even bring it up to a wild-ass guess. Okay, taking this stuff into beta decay, or beta plus decay. One, I'm assuming physics is wrong and the neutrino is a photon. I'm also assuming that we're using hypervortex model. So in this model, I'm taking a photon, which is a negative and a positive. So this is a high energy photon. It splits. The negative and positive add together. That'd be a electron and a proton add together to make a neutron and one positron. And this right here is what we see in beta plus decay. The neutron works in a certain way according to this model. The proton, and this one would be the electron. And if I'm going to put the dots where they're turning to, these arrows here coming here, this direction, they're going in the same direction, so even though they're a positive negative charge, the vortexes would be pulling themselves to each other. Same thing here, we go all the way around, all four ways, they're pulling towards each other. So these four spins, these four vortexes would hold themselves together. They would be spinning in this direction. Now the spins would be different because an electron has a lower energy, lower mass than the proton does. So as soon as these connect, they're going to change energies, and they'll have a different spin rate. The other thing you need to look at is spin up and spin down for both of them. Notice I have it this direction so that these arrows are both pointing outwards for the proton and the electron. However, if you were to reverse this like this, we would have virtually the same thing. All these arrows would be pointing the same direction, bringing them all together, except these outside arrows here would be going towards each other, and that would be pushing them away. So it is only stable one direction, making a neutron, and another proton wouldn't necessarily fit on the other side of the electron here, because it would be shoving it away from. So you can't have a whole string of them, or it's not likely to have a whole string of them. Also, they would have, like I say, different spins, different velocities and spin, because the center of each one of these goes at the speed of light. Be velocity conservation. So that covering the beta plus decay, going to the beta minus decay. We start off with a neutron, and it just either energy is added or something happens to it, and it splits up and it creates an electron. And when I say added energy to it, it's very likely that the resonance frequency inside or next to a proton, the resonance frequency of a proton keeps this system together. I think it's a 10-second neutron decay when a neutron leaves the inner core of an atom. So here we have electron capture, and we're taking an electron and a proton, and inside a nucleus, that means we have a nucleus of helium or more than one proton, so that an electron comes into the nucleus and goes around a bunch of times and eventually connects to one of them. And if it connects correctly, we have a neutron. Otherwise, we have a proton plus side that's taking the right-hand rule, spinning each vortex this direction, and right-hand rule on this one. So it's two positives spinning in that direction would be a proton. And on this one, we would have negative spin, even though they're spinning in the same direction, the systems. Notice the spin on this one is going this direction and the spin on that one is going the opposite direction. So this one here would be the electron, and it's using the left-hand rule for both vortexes going in that direction. And that would be the hypervortex model for the electron and the proton. The positron would look exactly like the proton, except for it has a different energy state. And it also has a different vibrational frequency. If we're looking at the electron, we'd be looking at both the electron and the positron, because they both have the same mass. So what I'm doing is I'm E equals mc squared, E equals also Planck's constant times frequency. So I take these, knock off the E, and I solve for frequency, and I get frequency equals mass times the speed of light divided by Planck's constant. So I'm adding the mass of the electron, speed of light squared, and Planck's constant, and I get a frequency of 1.236 times 10 to the 20th. There's a lot of different ways to get the diameter of an electron, and we don't have any observations of that electron frequency yet. So if we know the frequency of the center of it, we know the speed of the center of it, we know the diameter of it. Those three go hand in hand. For the neutron, we have two systems, so the mass is divided between both systems. Therefore, the diameter of these two systems is going to be divided by 2. It would be 1/2 times mass times speed of light over Planck's constant, and I'm getting 1.136 times 10 to the 23rd revolutions per second. And the proton is nothing more than the positive vortex, which would be the right-hand rule, spinning in that direction with excess mass, and it would have twice the mass. Therefore, it would have twice the revolutions per second. And that covers this video, and I'll see you on the next one.